Hi 6th graders, I hope you've been doing well. Today we are going to work on 6.3, which is all about proportions. Our learning target is I can identify proportions using unit rates and equivalent fractions. So we've talked about unit rates before. That's when you have a fraction or a ratio and your denominator is 1. Okay, and then equivalent fractions are when the two fractions are the same. Alright, so let's go ahead and let's get started. Our definition for a proportion is an equation stating that two ratios or rates are equivalent. So, starting with rates, we have $2 for 10 pints, and that is equivalent to $6 for 30 pints. So to figure out if these are a proportion, if these are equal, we need to go ahead and divide and find the unit rate. So what we are going to do is grab your calculator, and we are going to divide 2 divided by 10. 2 divided by 10 gives us 20 cents. So we get 0.2. And we're talking money per pint. Okay, now going over to our second one, we need to take 6 divided by 30 and see if it's the same thing. I got 0.20 cents per print as well. So since these are the exact same, these are proportional. So you would answer yes, they are the same. Moving on to a fraction. When we are looking at fractions, we want to figure out if they're equivalent. So we think 2 times what gives us 6? Well, 2 times 3 gives us 6. So what we do to the top, we also need to do to the bottom. What's 10 times 3? Is it 30? It sure is. So these two fractions are equivalent. And another way to check it, if you don't want to do the times 3 way, another way to check it is using the butterfly method that we've done before. 2 times 30 is 60. 10 times 6, that's also 60. So since those two numbers are the same, this is equivalent. Alright, so now we're going to take a look at some practice problems. So for number 1, we need to determine if the quantities in each pair of ratios or rates are proportional. So we have 20 miles in 5 hours and 45 miles in 9 hours. So first of all, we are going to set up two ratios. Our first one is 20 miles over 5 hours, and our second one is 45 miles over 9 hours. And the one thing we need to be super careful about when we're setting up our proportions or our ratios is that our miles are both on the top and our hours are both on the bottom. Okay, we couldn't have switched it because then it is not the same. You could have put hours on top and miles on bottom, but you couldn't have switched one of the fractions. Alright, so to figure out if these are equivalent, we could do two different things. We could find the unit rate, where we take 20 divided by 5, which is 4 miles per 1 hour. And then over here, 45 divided by 9 is also 5 miles per 1 hour. So we have 4 miles per hour and 5 miles per hour. Are those the same? No, they're not. So you would say, no, they are not proportional. Okay, so that's one way that we could do this to figure out if they are proportional. I'm going to show you another way for number 2. So number 2 is talking about 3 t-shirts for $21 and 5 t-shirts for $35. So first of all, set up our ratios. 3 shirts for $21 and 5 shirts for $35. Alright, here's another way we could do it. We could use the butterfly method. Cross multiply, take 3 times 35, and we get 105. So I would write that number up here somewhere, 105. Now do the same thing with 21 times 5. We also get 105. So since those two numbers are the same, these two are proportional. So we would say yes. Okay, so there's two different ways you could do it. You could find the unit rate, or you could cross multiply and make sure that they are equal. Alright, so let's take a look at our word problem. Felisa read the first 60 pages of a book in 3 days. She read the last 9 pages in 6 days. Are those reading rates proportional? Alright, so we have 60 pages of a book in 3 days, and then 9 pages in 6 days. So let's set up our ratios. We have 60 pages in 3 days, and we have 9 pages in 6 days. Alright, to figure out if those are proportional, you could do either way. You could cross multiply, or you could find the unit rate. For this one, I'm going to find the unit rate. So we're going to take 60 divided by 3, and we get 20 pages per 1 day. Okay, and then over here, 9 divided by 6, we get 1.5 pages per 1 day. Are these two unit rates equivalent? No, they are not. So they are not proportional. So that is your answer. Fabulous. Now we're going to move on to equivalent fractions. So we're going to be doing the exact same thing we were doing before. Three free throws made out of 7 attempts, and 9 free throws made out of 14 attempts. So go ahead and set up our ratio. We have 3 free throws over 7 attempts, and we have 9 free throws, I'm going to shorten it, over 14 attempts. Okay, so now we could do 3 times what gives us 9? Well, 3 times 3 gives us 9. Is 7 times 3 14? Nope, it isn't. So this is not proportional. Okay, so that's one way we could do it. Now I'm going to practice the other way with you over for number 2. The next one is 6 DVDs for $90 or 3 DVDs for $45. So set up your ratio. We have 6 DVDs for $90. This time I'm not going to include my labels, and that's okay. And we have 3 DVDs for $45. Okay, now we can use the butterfly method. 6 times 45 gives us 270. And then 90 times 3 also gives us 270. So since those two numbers are the same, these are proportional. Awesome, we have one problem left. One school survey showed that 3 out of 5 students buy their lunch. Another survey showed that 12 out of 19 buy their lunch. Are these results proportional? So let's go ahead and set up our ratio. First we have 3 out of 5. So 3 over 5. And then we got 12 over 19. Alright, so we can use the butterfly method. 3 times 19, oops, I typed it in wrong. 3 times 19 is 57. 5 times 12 is 60. Those two numbers are not the same, so these are not proportional. So your answer would be no. Alright, so there's a few different ways that you could figure out if they're proportional or not. Choose the one that makes the most sense to you, and use that as you work through the worksheet and the IXL. I hope you have a great rest of your day. Bye!